Hello students, welcome to Mechanical Engineering Wisdom channel. In this video, we're going to discuss basics of thermodynamics part 1. So, the topics covered in this video will be thermodynamic definitions, thermodynamic properties, equilibrium, process and cycles. So these are the basic of thermodynamics. So in this we'll cover these topics today in this video. So thermodynamic definitions. So thermodynamics is a science that deals with energy and its transfers. So it studies different circumstances where this energy is manipulated, that means it is changed to achieve a desired effect, means it's done in a controlled environment. So that is called manipulation. So thermodynamics is such a science that deals in energy and its transfers. So there are different applications of this science. Some of the examples are a steam power plant where a steam is converted into electricity. There is internal combustion engines, that is regular what we drive, both two-wheelers and four-wheelers. We make use of internal combustion engines. So there is refrigerators, there are air conditioners, there are compressors. So all these use thermodynamics principle for its functioning. So thermodynamics deals with such sciences. So let's come to the different terms used in thermodynamics. System. So it's a very common word. So in thermodynamics also there is a system. So its definition is it's a region or volume which we evaluate the thermodynamic properties with respect to the rest of the universe. That means we take a particular system and we isolate it and then study it. So that is particular region or volume, we call it as a system. So there are three types of systems when we deal with thermodynamics. The three are open system, closed system and isolated system. So there are three systems. This is very important. So in this there is a boundary. So it is an imaginary or real outline that separates a system from its surroundings. So it can be rigid or flexible. So all energy interactions to and from the system happens through this boundary. So boundary is like a gate where it is marks the outline where the system we study. So the system's interaction with the surroundings is separated by a boundary. So all interactions happen at this boundary. So that's very important. So surroundings, the region beyond the boundary of a system is called a surrounding. So just check out this diagram. So there is an outline and that is called the boundary. There is a system inside where the interactions, thermodynamic interactions take place, and the surroundings where the surrounding affects this system's behavior constantly based on the system performance. So there are different types of system. When it's called an open system, a system where both mass and energy transfer takes place between a system and its surrounding, it's called an open system. That means there is mass transfer, that means there is physical mass transfer and there is energy transfer. So energy is converted into work. So open system, there is both mass and energy transfer. For example, a human body. So we drink water, eat food, breathe air. This is input of energy. We walk, we run, we push. This is the energy output, making use of that input of energy. A closed system. A system which allows only transfer of energy to and from the system is known as a closed system. For example, a bottle filled with hot water and closed by a lid. Only heat energy can transfer, but no water as lid is closed. Isolated system, a system in which neither mass nor energy can be transferred from or to the system. For example, a thermos flask. So thermos flask is in early stages. There will be no heat transfer or there will be no fluid transfer, that is mass transfer. So control volume. When the volume of the system is fixed, it is called control volume. An open system is the best example of control volume. So please check out this diagram where there is a mass flow and there is a system where the volume is controlled and there is also a surface. So this is called control volume, the volume which we study for thermodynamic interactions is called control volume. So next goes to thermodynamic properties. So what is a property? So a property is a character of a system and has fixed value at a given point at a given time. So the definite value of a set of characteristics is the states of a system. So the result in the change of value of characteristic referred to as change of state. So common thermodynamic properties are pressure, volume, density, energy, etc. So they are further classified into intensive and extensive properties. So what is an intensive property? So intensive properties are those which are independent of mass. Means no matter how much mass is there or present, it value doesn't depend on mass. So example is pressure, temperature. So extensive properties, properties which depend on mass, means when there is increase or decrease in the mass, the property value changes. So such examples are volume, density. Specific property. So specific property is extensive property can be changed into intensive property, means we make an extensive property dependent on mass. So when we divide with mass, so we get specific property. So the examples are specific volume. So next is phase. A quantity of matter homogeneous in chemical composition and physical structure is called a phase. So it contains a homogeneous, means a single type of chemical composition in the physical structure. So that is called a phase. So every substance can exist in any one of the three phases, that is solid, liquid and gas. A system containing of a single phase is called a homogeneous system, while a system consisting of more than one phase is known as heterogeneous system. That means heterogeneous means in this system there will be two phases, either there will be a combination of a solid and a liquid, or a semi-solid, or a liquid and a gas. That is called a heterogeneous system. So next go to equilibrium. So when there is no change in the existing state, then that system is said to be in equilibrium. In thermodynamics, there are three types of equilibrium that is need to be considered. That is mechanical equilibrium, chemical equilibrium and thermal equilibrium. So what is mechanical equilibrium? A system is said to have achieved mechanical equilibrium when the pressure or force remains the same throughout the system. So that is when the pressure or the force is constant throughout the system, then the system is said to be in mechanical equilibrium. Next, chemical equilibrium. If a system does not vary in chemical composition and does not have any modification in mass, that means there is no change in the mass, the system is said to possess chemical equilibrium. So next is thermal equilibrium. If the system experiences the same temperature throughout, then it is said to be in thermal equilibrium, means the temperature, there is no temperature gradient, the temperature gradient is 0, then it is said to be in thermal equilibrium. So next, process and cycles. So at this initial stage, we will assume that any gas will obey ideal gas law, PV is equal to RT. So some of the definitions are path. So the path states connected by a curve as the system changes its state due to external or internal disturbance. So when there is a change in the extensive or intensive property, so it follows a particular state. So that is used by connecting those changes, we get a curve, and that curve is said to be in a particular path. A process, a path defined by a distinct mathematical rule or relation is called a process. So we have the diagram for the process where a system is changes from initial to the final volume. So it is a piston cylinder arrangement. So when the piston moves at a certain stage, the volume changes. So the pressure increases, the volume decreases. So this is a particular path, and it's called a process. Reversible process. A reversible process is a process in which path can be traversed in either direction without any change to the system or surroundings. That means the initial process and the final process can be reversed. So that is called reversible process. So irreversible process. An irreversible process is the one in which the path can be traversed in one direction only. So you cannot come back to the initial position. Isothermal process. An isothermal process is the one in which temperature remains constant. An isobaric process. An isobaric process is the one in which pressure remains constant. Isochoric process. An isochoric process is the one in which volume remains constant. Isenthalpic process. An isenthalpic process is the one in which enthalpy remains constant. Adiabatic process. An adiabatic process is the one in which no exchange of heat energy takes place. Isentropic process. An isentropic process is the one in which entropy remains constant. Polytropic process. A polytropic process involves a series of change of states the system undergoes continuously without any gap between successive states. Next is quasi-static process. A quasi-static process is the one which proceeds infinitesimally slowly so that there is no disturbance to the conditions of the system and or surroundings. Therefore, by definition, it is also a reversible process. Next is cycle. A series of processes is known as cycles. A complete cycle is the one in which the system returns to its original, that is, it starts at a certain point and returns back to that original point. In such cases, there is no variation in the properties of the system at the beginning and at the conclusion of the cycle. If all constituent processes are reversible individually, then the whole cycle is said to be a reversible cycle. Otherwise, even if one of them turns out to be irreversible, the entire cycle becomes irreversible. So at any point in the process of the cycle, the condition of the system can be described by any one of the two independent properties, only two property rule. Therefore, the change in conditions of the system can be plotted using any two of them as coordinates, like pressure and volume, pressure and temperature, temperature and volume, etc. So this is the basic thermodynamics part 1. If you like the video, please subscribe to our channel and press the bell icon button for latest updates. Thanks for watching.